Welcome all of you to this video of Maths Made Easy. Now today I am taking up one physics topic. As you can see, this is spherical lens. You have already understood from the thumbnail. So this is concave and convex lens. Today I am going to take up the different ray diagrams. Okay, and I'm going to tell you why and how you can stop getting confused about these ray diagrams, because it is very common to draw a wrong ray diagram or get confused about these ray diagrams. Sometimes you draw convex for concave, concave for convex, like that. So please watch the video till the end, because till the end, believe me, you'll be having something to learn from each of these diagrams that we are going to draw. Okay, so as I proceed with the entire video, keep watching it, and the next video that I'm going to take up is the numericals based on concave lens and convex lens, and that video will be, why I'm telling you to listen to this carefully, is that video will be completely dependent on this theory. Okay, if you don't know this well, you will not be able to do your numericals well. So let us start quickly. So this is our first we will talk about what a lens is. Before this we have talked about a mirror. Okay, now the basic difference between a mirror and a lens is mirror was a reflecting surface. Okay, that means one side was opaque. Light could not pass through it. Okay, now here we have a transparent. Now here we have a transparent medium. Okay, like it's like you must have seen a lens of a magnifying glass. So it is a transparent thing. None of the sides are opaque. Okay, here you have silvering. That is, if you see behind a mirror, whether it's a plane mirror, concave mirror, or convex, as long as it is a mirror, it will have that. Silvered side, that red paint kind of thing behind it. But then this one will not have it. Okay, it is a transparent medium for refraction. इससे क्या होता है? इससे होता है रिफ्रैक्शन, इससे होती है रिफ्लेक्शन, और इससे रिफ्रैक्शन. ठीक है, सो रिफ्रैक्शन और रिफ्लेक्शन में पहले डिफरेंस समझ लेते हैं. रिफ्लेक्शन में जिस मीडियम से लाइट आता है उसी मीडियम में लाइट लौट कर चला जाता है. ओके, सो लाइट गोज बैक, gets bounced back into the same medium. Here light will come and pass through this. Okay, so as it passes, see, it has gone through another medium, and as it goes through another medium, there is going to be a bending. Okay, now what kind of bending we already know, because once we start with lens, हम एक बार हमने लेंस शुरू कर दिया, इसका मतलब हमें रिफ्रैक्शन का मतलब पता है. तो फिर लेंस क्या होता है? लेंस जो होता है ना, हम इसको लेते हैं कुछ ऐसा कि ये जो साइड है इसका, ठीक है, ये जो साइड है इसे हम समझ लेते हैं कि एक स्फीयर का एक पोर्शन है, और ये जो साइड है ये भी एक और स्फीयर का पोर्शन है. यानी कि there was a sphere here of which this is a part, there was another sphere here of which this is a part. Okay, now that has made this refracting medium. Now we have two types, दो lenses है CBSE या ICSE portions में, ICSE syllabus में. That is, one is this, and that is this is concave, and we have convex. Okay, we have two types of lens. This is biconvex, this is biconcave. ओके, तो नाम ऐसा बाई क्यों आता है? क्योंकि काफ़ी सारा और भी टाइप्स ऑफ लेंस होते हैं जो आपके सिलेबस में नहीं है, जैसे कि प्लेनो कॉन्वेक्स, या फिर हो गया प्लेनो कॉनकेव, ऐसे वाले. ठीक है, तो ये जो है कॉनकेव एंड कॉन्वेक्स, ये है हमारा दो लेंस जो हमारा सिलेबस में है. तो अभी देखते हैं इस लेंस में कौन सा क्या पार्ट होता है. ठीक है, तो फिर इस पार्ट्स के लिए देखिए, पहले तो कॉन्वेक्स ले लेते हैं. राइट पासिंग थ्रू राइट द सेंटर, पहले तो ज्वाइनिंग, देयर इज अ लाइन, दिस इज द एक्सिस, वर्टिकल एक्सिस, एंड दिस वन, द लाइन विच passes through the center of the lens. Okay, this line passes through the center of the lens, because the lens is, like what you've seen in a magnifying glass. It's like a disc. It's like a disc which is like it, which is convex on both sides. It's like kind of, I can say it's like the palm of my hand. Okay, you see how it is. Okay, so that is a lens. Now this line which is passing through the center is called the principal axis. You already know it. Okay, the principal axis. Okay, now here we have the O. O is the optical center. Now this is going to be same for कॉनकेव एंड कॉन्वेक्स, दोनों में ये चीज़ें जो है सेम ही होती है, इसमें कुछ खास नहीं है. अब यहाँ पे है फोकस. ओके, तो एक बात मैं यहाँ आप लोगों को बताना चाहती हूँ कि आपके ध्यान में लाना चाहती हूँ, आपको पता होगा लेकिन फिर भी मैं एक बार बता दूँ कि मिरर्स में एक ही फोकस था, एक ही सेंटर ऑफ कर्वेचर था, ठीक है, लेकिन लेंस में दो फोकस और दो सेंटर ऑफ कर्वेचर. ओके, क्योंकि लाइट इधर से भी आ सकती है. अगर लाइट इधर से आ रही है तो ये वाली फोकस काम करेगी, अगर लाइट इधर से आ रही है तो वी नीड दिस फोकस. ओके, तो फिर ये हो गया फोकस, लेकिन हम इसको बोलेंगे F1 एंड देन 2F1. हम सेंटर ऑफ कर्वेचर नहीं बोलते यहाँ हम बोलते हैं 2F1. ओके, इधर हो गया फ्रॉम एट द सेम डिस्टेंस, दिस डिस्टेंस हैज़ टू बी इक्वल. ओके, दिस डिस्टेंस optical center to focus distance has to be equal on both sides. F2, this is our second focus, and this is 2F2. Okay, so that is all we need in a lens. If we have a concave lens, the same diagram only will change here to a concave. So the same diagram will change to concave lens. This is the concave lens. Okay, same thing. So how do you remember? Sometimes we can't even remember to we don't remember the names. What to do? Okay, so concave is the one which is caved inside. See, it is caved inside like this. Okay, convex is the one which is not caved. So that is why you have to have some way to remember. So this is the parts of a lens. Coming to now, first thing I am going to take up two things. Here don't confuse. When you see, आप टेक्स्ट बुक खोलते हैं, आप उसमें देखते हैं डिफरेंट लेंस के डायग्राम्स देखते हैं, और फिर आप देखते हैं केसेस भी देखते हैं. आप बिल्कुल कंफ्यूज हो जाते हैं क्योंकि आपको समझ में नहीं आता है रूल्स कौन वाली है और केसेस कौन वाली है. आप बिल्कुल ही कंफ्यूज रहते हैं. Okay, now what I am trying to tell you is start differentiating between the rules and the cases. Okay, cases is little different, rules is little different. Okay, so I'll start with, there are three rules for this lens and for the convex lens, and then we'll start with the cases. So let's start with the rules. First, convex lens. Okay, first is convex lens. In convex lens, first thing, so this is our convex lens. This here is my optical center. Okay, now when you draw this lens, again I am telling you, people draw the lens like this. Some people even take आप कंपास ले लेते हो. ओके, कंपास लेके इसको बनाने की कोशिश करते हो, आप ऐसा बना देते हो. ओके, ये आपको नहीं करना है. क्यों नहीं करना है मैं बाद में बताती हूँ. तो फिर ये जो हो गया हमारा लेंस, इसमें इफ फर्स्ट रूल नंबर 1, रूल 1, इफ रेज आर कमिंग फ्रॉम इन्फिनिटी. नाउ इफ रेज आर कमिंग फ्रॉम इन्फिनिटी, हम उसको हमेशा पैरेलल ही लेके चलते हैं. ओके, देन इफ दे आर कमिंग पैरेलल तो अपने आप में होगा. इफ दे आर कमिंग पैरेलल टू द प्रिंसिपल एक्सिस, देन दे कन्वर्ज एट द focus. Okay, they converge at this focus. If they are coming from this side, they will converge at this focus. Okay, so they are converging at F1. Next is, they can also come parallel to each other but not parallel to the principal axis. Like they can come, they can still come like this, somewhat like this and like this. They are parallel to itself but not parallel to the principal axis. Even then they do converge, this time not at the focus, but where do they converge? They converge at in the focal plane. So understand the difference between these two. They are more or less the same thing. So here arrows are important, don't forget the arrows. So here they converge in the focal plane, means if I hold a sheet of paper, okay, if I hold a sheet of paper parallel to the lens, it will be formed in that sheet of paper only. That's the meaning of focal plane. Okay, so convex lens, this is rule 1. Okay, let's talk about the other rule, which is rule 2. Rule 2 for convex lens is if two rays, okay, I'll change this diagram only and make, okay, if two rays are coming through the focus, that is they are coming like this, okay, somewhere you are holding a torch here maybe, so these rays, one ray is coming through the focus, or it's coming, another ray is coming through the focus, that is passing through the focus, okay, then it will go parallel to the principal axis. Why I could use the same diagram? क्योंकि एक दूसरे का रिवर्स था, इसीलिए मेरा सेम डायग्राम से काम चल गया. ओके, सो फोकस से अगर रेज आएगा तो पैरेलल टू द प्रिंसिपल एक्सिस जाएगा, और अगर पैरेलल टू द प्रिंसिपल एक्सिस आया या फिर इन्फिनिटी से आया तो फोकस या फोकल प्लेन में जाके मीट करेगा. तो फिर जहां रेज मीट करते हैं वहीं पे हम बोलते हैं कि इमेज इज फॉर्म्ड. ओके, क्यों यहाँ पे इमेज फॉर्म्ड बोलते हैं? जब रेज यहाँ मीट किया तो हम बोलते हैं इमेज इज फॉर्म्ड हियर. इसमें तो नहीं, इसमें रेज आर नॉट मीटिंग, हियर रेज आर मीटिंग हियर, तो हम बोलते हैं इमेज इज फॉर्म्ड हियर. क्योंकि यहीं से हम जब अपनी आई को प्लेस करते हैं, व्हेन वी प्लेस आवर आई, तो वी गेट द फीलिंग कि रेज आर कमिंग फ्रॉम हियर. दैट इज वाई हमें ऐसा लगता है कि इमेज इज फॉर्म्ड एट द फोकस. ओके, नाउ what is the third rule? So first rule was parallel and second rule was through the focus. Rule 3 is even more simpler. Rule 3 is a ray passing through the optical center passes away straight. A ray coming through the optical center passes away straight. Okay, so there is no deviation here, no bending here, it just passes away straight as if there is no lens. Okay, this is the optical center. Now I want to talk about this. इसके बारे में कुछ तो मुझे इंटरेस्टिंग बातें करनी है. लेंस को ना जो है हम एक्चुअली लेंस को हम ले लेते हैं 3 डिवीजन में, 3 डिविजन्स. एक this part, upper part, one is the lower part and one is the central part. Upper part we say is a straight prism, lower part we say is an inverted prism. Okay, और बीच वाली जो part है ना उसे हम बोलते हैं it behaves like a glass slab. Okay, तो straight prism में light जाएगा तो वो डाउनवर्ड बेंड होगा, इन्वर्टेड प्रिज्म में भी अपवर्ड बेंड होगा, क्योंकि आपने प्रिज्म किया होगा तो प्रिज्म में बेंडिंग वैसा ही होता है. जिस साइड प्रिज्म का लाइट ऐसा जाता है, ऐसा जाके फिर ऐसा जाता है, तो यही चीज़ हम बोलते हैं कि यहाँ पे हो रहा है और यहाँ पे हो रहा है. ओके, और ये जो पार्ट है ना सेंट्रल पार्ट, ये है एक ग्लास स्लैब जैसा. अगर ग्लास स्लैब जैसा ही है तो फिर अगर सेंट्रल पार्ट से जा रहा है तो फिर वो क्यों नहीं बेंड हो रहा है? क्योंकि हमारा तो लैटरल डिस्प्लेसमेंट था. व्हेन ग्लास स्लैब में, रिमेंबर ग्लास स्लैब वाली डायग्राम, इसमें रे ऐसा जाता है फिर ऐसा और फिर ऐसा, और हमने ऐसा कहा था लैटरल डिस्प्लेसमेंट, रिमेंबर. यानी कि बिकॉज ऑफ द स्लैब द रे गॉट इमर्जेंट रेज डिस्प्लेस्ड. तो इसमें क्या हो गया? अब अगर हम बोल रहे हैं कि ये ग्लास स्लैब है, ग्लास स्लैब जैसा बिहेव कर रहा है, तो फिर स्ट्रेट क्यों जा रहा है? डिस्प्लेस तो ये भी होता है, इवन दिस गेट्स डिस्प्लेस्ड, बट देन बिकॉज द लेंस इज अ वेरी थिन थिंग, ओके, वी नेग्लेक्ट द डिस्प्लेसमेंट व्हेन द रे पासेस थ्रू द ऑप्टिकल सेंटर. यहाँ पे इसको नेग्लेक्ट किया जाता है. तो रिमेंबर इसका एक क्वेश्चन आ सकता है, इफ द रे इज पासिंग थ्रू द ऑप्टिकल सेंटर, व्हाई देयर इज नो डिस्प्लेसमेंट और व्हाई देयर इज नो बेंडिंग when the ray passes through the optical center? Why there is no deviation? Okay, the reason is there is deviation, but it is neglected because the lens is considered to be very, very thin. Okay, so that is your answer, and that was the 3 rules. Okay, let me come to the rules of, okay, let's start with the cases of convex lens. Case 1. Now what are cases? Why I am telling again and again cases, rules, cases, rules. Rules are वो वाली चीज है जो हमें सिखाता है कि लाइट इफ इट इज पासिंग थ्रू अ लेंस तो बिहेव कैसा करेगा किस केस में. केस जब हम शुरू करते हैं तो हम लेके चलते हैं कि ऑब्जेक्ट का पोजीशन क्या है, अकॉर्डिंगली इमेज कहाँ फॉर्म होगा. इसमें 6 केसेस है इन कॉन्वेक्स लेंस, तो हम देखते हैं 1 by 1. दिस इज केस 1. सो हियर पहला तो ऑब्जेक्ट एट, ये हो गया ऑप्टिकल सेंटर, और पहले ही आप जहाँ इसका रे डायग्राम शुरू कीजिएगा ना, पहले ही आप F1 2F1 और F2 और 2F2 आप नोटबुक में करेंगे तो आपके लिए ये ईजी रहेगा कि यहाँ पे आपने मेजर कर लिया 2 सेंटीमीटर, तो इधर भी आप 2 सेंटीमीटर ही कीजिए. मैं आई एस्टिमेशन से कर रही हूँ. ओके, और फिर इसको भी अगर आपने यहाँ 2 सेंटीमीटर लिया तो F1 to 2F1 शुड ऑल्सो भी 2 सेंटीमीटर, दिस शुड ऑल्सो भी 2 सेंटीमीटर. ओके, आपको बोला तो नहीं जाएगा, लेकिन रे डायग्राम जब मांगते हैं तो फिर आपका डायग्राम और भी ज़्यादा एक्यूरेट हो जाएगा अगर आपने मेजर करके लिया हो तो. ठीक है, तो फिर ये हो गया डायग्राम रेडी. अब शुरू करते हैं. केस 1, व्हेन द ऑब्जेक्ट इज एट इन्फिनिटी. व्हेन द ऑब्जेक्ट इज एट इन्फिनिटी, इमेज इज कमिंग, rays are coming from infinity, they are parallel to one another and they converge at the focus. So this is my diagram for object is at infinity. Okay, now that is not over. We will have to write image is formed here, but it becomes very small, diminished to a point. Okay, now what we have to write is characteristics of the image formed. Here case 1, object at infinity. Okay, so case 1, object is at infinity. Characteristics, let's talk about the characteristics now. Characteristics is of the image. Okay, we don't talk about the characteristics of the object, characteristics of the image. This is image is real. Now why is image real? How do we know? कैसा पता चलेगा? क्योंकि जहाँ रेज एक्चुअली मीट करते हैं वहाँ रियल इमेज फॉर्म होता है. अगर रियल है तो इन्वर्टेड होना ही है, इस बारे में तो सोचना ही नहीं है. ओके, रियल इमेज इज ऑलवेज इन्वर्टेड. एंड एट F, that is at focus, for this side object हम एज्यूम करके चलते हैं अगर रेज इन्फिनिटी से आ रहे हैं तो हम ऑब्जेक्ट नहीं ड्रॉ करते. ओके, सिर्फ उसमें से आ रहे हैं जो रेज को ड्रॉ कर लेते हैं और वो जाके फोकस में मीट करता है, तो फिर इन्वर्टेड एट फोकस. ओके, तो इधर वाले ऑब्जेक्ट के लिए ये फोकस है, दे मीट एट फोकस, हाईली डिमिनिश्ड. Okay, this is highly diminished. So these are the characteristics must write, and this measurement is a must. Let's talk about the next one, which is case 2. Okay, now case 2, object beyond 2F2, because if I am considering this as 2F1. Okay, now what? Now see here, this is the object, here is F2, here is F1, this is 2F1, this is 2F2, and now the object is on the principal axis but here. Okay, now this is our next case. Object is on the principal axis but beyond 2F2. You can see 2F2 is here, I am keeping it outside 2F2. Now one ray. Now you will see how I'll be following the rules. Here also I had followed the, even here I had followed the rules. These rays went parallel to the principal axis, they met at the focus. I was following rule 1. Here I am following one ray goes parallel to the principal axis. And another thing I want to tell, आप रे को तो ले तो जाएंगे, प्लीज स्केल एंड पेंसिल से ड्रॉ कीजिए और इस लाइन पे जाके बेंड कीजिए, यहाँ पे नहीं बेंड कर दीजिएगा. Okay, now it bends at the focus. Okay, the other ray will, अब जो थर्ड रूल था उसको फॉलो करेंगे, will pass through the center of curvature and अभी ये जो रे है ये जा रहा है थ्रू O. ओके, इट इज पासिंग थ्रू O और O से जाने से ये मीट कर रहा है पहले वाली रे को इधर एंड द इमेज इज फॉर्म्ड. So it meets here and the image is formed here, that is between F1 and 2F1. Okay, so object beyond 2F, if I write characteristics, image between, you have to write like this, F1 and 2F1. Okay, again this is a real one, definitely real because rays are actually meeting and inverted. Rays are actually meeting and it is inverted. Also it is smaller in size. We don't say smaller in size, we say diminished, but not, it is diminished but it is not highly diminished. Okay, it is diminished but not highly diminished. Now what are the important things that you have to keep note? Firstly, this measurement. Second thing, arrows. Okay, third thing, very very neat diagram. Okay, so please draw with a pencil. So here you saw that we followed two of the rules that we learned, going parallel to the principal axis, and this is going through the optical center, that rule, rule 3. Okay, let's come to case 3. Okay, now the third case, what is the third case? This is lens optical center. This is F1 to F1, F2 to F2. Now आप एक चीज़ नोट कीजिए कि जैसे जैसे मैं केसेस आगे कर रही हूँ, ऑब्जेक्ट जो है ना वो धीरे धीरे लेंस के तरफ जा रहा है. ओके, तो वो धीरे धीरे लेंस के तरफ जा रहा है. तो पहला इमेज हमारा था फोकस में, दूसरा इमेज इसके बीच आ गया था. ओके, अभी तीसरा इमेज देखते हैं कहाँ. तो ऑब्जेक्ट जैसा जैसा लेंस के नज़दीक जा रहा है, इमेज उतना ही लेंस से दूर जा रहा है. देखते रहिए. तो नाउ हियर ऑब्जेक्ट विल बी एट 2F. ये जो डायग्राम है ना काफ़ी हद तक आपका लेंस में मिरर में सेंटर ऑफ कर्वेचर वाली डायग्राम जैसा है. ऑब्जेक्ट एट C. नाउ यहाँ से एक रे गया पैरेलल टू द प्रिंसिपल एक्सिस. ये वाली रे गई पैरेलल टू प्रिंसिपल एक्सिस. इसके लिए हमें रूल 1 पता है, इट विल कन्वर्ज एट द फोकस. इसे कन्वर्जिंग लेंस भी बोला जाता है क्योंकि ये रेज को कन्वर्ज करता है, यानी कि रेज को एक दूसरे से के पास लाता है. दूसरी वाली अभी जाएगी ऑप्टिकल सेंटर में से, और अगर आपने ये मेजरमेंट्स ठीक लिया है तो ये जाके, और अगर आपने मेजरमेंट्स ठीक लिया है तो ये जाके बिल्कुल ये जो 2F1 है ना उसके नीचे आ जाता है, उसके नीचे मीट करता है, यानी कि द इमेज इज फॉर्म्ड एट 2F1. सो हियर कैरेक्टरिस्टिक्स क्या होता है? कैरेक्टरिस्टिक्स, व्हाट इज द कैरेक्टरिस्टिक्स ऑफ द इमेज फॉर्म्ड? पहला तो ये रियल है. ओके, ये है रियल. ओके, एरोज देना मत भूलिए. दूसरा है इन्वर्टेड. पोजीशन क्या है? दे विल से पोजीशन एंड नेचर. ये जो है ये नेचर के अंदर आता है. पोजीशन क्या है? पोजीशन इज एट 2F1. image is formed at 2F1. it is real, it is inverted at 2F1, and then image is formed at 2F1. it is same size as the object. So if you just write characteristics of image, you can just write same size as that of the object is formed. Okay, so that is case 3 when the object was at the 2F2. Let's come to the next case, which is case 4. Again we have a lens, and now principal axis, this is the optical center, and this is F1 to F1, F2 to F2. Okay, अभी जाके तो आप लोग बहुत समय आप लोग बोलेंगे कि हमारा तो इमेज जगह पे नहीं आ रहा है, 2f1 में नहीं आ रहा है, साइज में छोटा, इट इज बिगर इन साइज दैन द ऑब्जेक्ट, इट इज स्मॉलर इन साइज दैन द ऑब्जेक्ट, so I am not getting the required size of the image also. So you will get all types of complaints like this. Now the only rule for that is to firstly use a scale, no freehand diagram, and second thing is to measure this correctly. If you measure these distances have to be all equal, then you will definitely get your result correct. Now here till 2f object had come. Next my object is here, it is between f2 and 2f2. This is the object here. Yes, okay, this ray is going parallel, it will converge at the focus. Now the other ray will go through the optical center, and now see where it meets. Okay, if you see, it has met beyond 2f. Yes, so the position of the object is actually, write this here, 2f1. Now you see it has met beyond 2f, and if you note the size, okay, so here real image inverted goes along with real, enlarged, you have to write the word enlarged, not image is bigger than the object, don't use all that, enlarged image. Okay, don't write highly enlarged, and then this is beyond 2f1, then it comes beyond 2f1. Okay, so these are the characteristics of the image formed. Don't forget the arrows. Okay, so this is the image. Okay, now here I want to talk about one thing. Now why do we always take this point only? Now the object is giving out. Okay, that is one point of confusion that students don't understand. Why only this point? And you know what students take it for? They take it for a candle, or they take it for a lamp. It's not like that. When I'm seeing I'm seeing this duster in front of me. Okay, this is not a candle, this is not a lamp, this is nothing like that, it's not a luminous body, but still where is the light coming from? The light is coming from, and how am I seeing it, and where is the light coming from? The light is coming from reflected light, because I have lights in the room. Okay, those lights are coming on this, those lights are incident on this, and from there they are reflecting to my eye. So it is not that if this becomes the object, only this tip of it will give out light, the entire body of it will give out light. Okay, the entire body of it is reflecting light to my eye, and only then I am seeing it. Okay, it happens for everything in my room, everything. So then why do we draw only this? Okay, why do we draw only this? Only reason why we draw only this is the upper limit. So we are drawing the upper limit that will help us to get the size of the image. Okay, actually the entire body of the object is giving out rays like this, like this, but we can't draw so many. It will confuse you, and it's not practical also. So we are just drawing the upper limit, which is the maximum limit, so that we get the maximum limit of the image. That's all. So please remember that this is not a luminous body, but it is just an object of which we are getting an image. 4 cases over. Now let's take the 5th case. Case 5. Okay, what is the 5th case? Here we have the lens here, and we have the optical center here. We have the optical center here. Now the rays are coming. Now here I have f1, 2f1, f2 and 2f2. Rays are coming from this. Rays are coming from the. Now this time, where is the object? The object is, it was here in between this. Now the object has shifted more. It has come to the focus. Here goes the ray, here it goes. Okay, and then the other one will also pass through the. So I'm following the rules. All the cases I've only followed the rules. So if you know the rules, you'll be able to do it. Now note one thing, these two rays, one is coming through the optical center, one through the focus, they don't meet. They are parallel rays, and we say that parallel rays meet in infinity. Okay, so image is at infinity. Image is at infinity. Okay, this time image is at infinity, and image is at infinity for object at focus. Image is at infinity. Next, so if they meet, if they're parallel lines meet at infinity, hence the image is at infinity. Highly enlarged. Okay, also real and inverted. Okay, this is also real and inverted. So these are the characteristics. Okay, now we'll come to the last diagram, the last case. F1 to F1, F2 to F2. Okay, now the object is placed between the optical center, between O and F, between the focus and the optical center. So it's between the focus and the optical center. Now here I'll place it here. Now see. Okay, here now what will happen is one ray will go parallel and it will pass through the focus, rule number 1. Okay, now the second ray will go through the optical center. This I am following rule 3 and it is going to go straight. Okay, but then note something, these two are not meeting. They are, you'll see if you have drawn these correctly, they are spreading out, they are diverging. Now if they are diverging, then you can actually draw them backwards. Yeah, you draw them backwards, and okay, if you extend them backwards, that is you hold the scale and then you extend. Okay, when you hold the scale and then you extend, this is where they meet. Now when you look at the lens from that side, you get the feeling that the rays are coming from here. Okay, the rays are coming from here. You feel that the rays are coming from this point, but remember, this is a virtual image. Rays didn't actually meet to form it, they seemed to meet. So this is a virtual image which will be drawn by dotted lines. Okay, so this part is also dotted lines, this part is also dotted lines, because this is just an illusion. Okay, so the image gets formed here, virtual image. Now I am not saying the image is formed at 2f. This position of the image and the size of the image can keep on changing depending on where you have placed the object. Have you placed the object right after focus, or have you placed it more that side? According to that, this is going to change. Also, it is going to change with the size. This size will change. Okay, so that is not that it is positioned at 2f2, nothing like that. It is just behind the lens. You have to say behind the lens. So behind the lens. Okay, where is not at all a point here. Next is virtual. This time it is virtual, definitely virtual. Okay, and this time it is erect. Virtual and erect will always go together, and it is enlarged. Now can you tell me which diagram is it? Okay, you can post in the comment box which diagram, where do we use this case of a convex lens. Okay, and what is the object in this case? This object, what is your object when you are using this case, and which case am I drawing this diagram? Let me know in your comments. Okay, so you can observe here that there is only one virtual image in all 6 cases of convex lens. Okay, rest all are real and inverted, only one virtual. Okay, so this is a very important diagram. Please draw it several times before going to your exams. Next, what we have to do is the concave lens. Okay, concave lens, here we'll also have, first we'll talk about the rules of the rules. So again, rule 1 for concave lens. This is our lens. Okay, and this is the principal axis. If rays are coming from infinity, here also you should draw a line. Okay, if rays are coming from infinity, that means they are parallel to each other, then they will diverge. This is called a diverging lens for this reason, because rays diverge. And if you hold a scale and if you extend this and you extend this line also backwards, this has to be in a straight line. This becomes a mistake, they get a dotted and then a ray like this, which is wrong. Okay, you have to have a straight line, it has to be in line. So they will meet at a point which will be called the focus. So this is how the rays diverge in this kind of a lens. And so for this, the focus, earlier one convex lens में focus जो था ना वो आपका इधर था, इसमें focus आ गया इधर, ऑब्जेक्ट भी इधर और फोकस भी इधर. ओके, तो हम जब इधर से देखते हैं लेंस को तो हमें ऐसा लगता है कि रेज इस पॉइंट से आ रहा है. सो इसमें डेफिनेशन ऑफ फोकस ऑफ कॉन्केव लेंस में बोला जाता है कि द रेज सीम टू कम, द रेज सीम टू डाइवर्ज फ्रॉम द फोकस विच दे एक्चुअली डोंट. ठीक है, उसमें तो कॉन्वेक्स में दे एक्चुअली कन्वर्ज. Okay, so this is one rule, that if they are parallel to the principal axis, they will diverge as if from the focus. The next one is, again, this is a concave lens, and what will happen now is, now here is the optical center. Okay, now in this, if the rays are coming from, if a ray is directed at the, here let's assume we have the focus here. Okay, then if a ray is directed at the focus, okay, means a ray is coming in such a direction that it will pass and it is directed at the focus, it cannot meet because of this lens, it cannot meet here, it will only seem to meet. Okay, then this ray goes parallel to the principal axis. So here you see just a reverse of this. This ray is coming as if directed at the focus, then it has to go parallel to the principal axis. Same thing down here. Okay, so it is a ray going parallel to the principal axis. That is our rule 2. Okay, let's come to rule 3, which is quite similar to that of the other one, the convex lens. A ray directed at the optical center. This is rule 3. Okay, a ray directed at the optical center passes straight through it without any deviation. I have talked about it in convex lenses. Okay, so it passes straight through the optical center. So this is my third diagram. Okay, this is my third rule for concave lens. Now we are going to use these rules in our further cases of concave lens. But the good news is that concave lens has only 2 diagrams. Okay, 2 diagrams, and concave lens gets over, it does not have 6 diagrams. So this is our next diagram. Now ray can be anywhere in front of the lens. It can be anywhere in front of the lens. Okay, now object can be anywhere in front of the lens. So I am placing the object here. Okay, it is between this and infinity, anywhere in front of the lens. Okay, it's not that between f2 and 2f2. One ray goes like this, parallel to the principal axis. Following the rules, what to do? It will diverge like this. Okay, so you have to draw a scale. That is why I am drawing this first. Okay, so this is diverging like this as if coming from the focus. Rule 1, right? Now the other ray is going through the center of curvature and it passes away straight. See, this is without deviation. Okay, so as it passes, the person seeing it from here gets the idea that the rays are coming from this point. So image is formed at this point. This is a virtual image. Okay, I have drawn it with dotted lines. Note here. Okay, so this is virtual, definitely erect. Okay, between F and O, F and O, focal optical center and focus. Okay, erect, and it is erect and it is diminished. Okay, this is erect and diminished. This is my final image, which is a erect image. Now I want to tell you here you will note one thing, you should note one thing, that both the images of concave lens is only virtual. Okay, and both of them are diminished. We have one virtual lens, one virtual image in convex mirror, convex lens, which is virtual but it is enlarged. So that is something you must remember. And ये आगे जाके नेक्स्ट वीडियो में मैं करने वाली हूँ, मैं आपको मैं एक वीडियो बनाने वाली हूँ न्यूमेरिकल्स पे, लेंस के न्यूमेरिकल्स पे। तो आप उसमें देखेंगे कि यही जो कॉन्सेप्ट है कि कहीं पे वर्चुअल तो है लेकिन है डिमिनिश्ड, या फिर कहीं वर्चुअल है एनलार्ज्ड है, ये किस तरह हमें न्यूमेरिकल्स को करने में न्यूमेरिकल्स को करेक्ट करने में हेल्प करता है। ओके, तो आज के लिए इतना ही, मैं यहीं पे स्टॉप करती हूँ क्योंकि ये था हमारा लास्ट केस। ठीक है, तो आगे जाके मेरा जो नेक्स्ट वीडियो होगा वो होगा न्यूमेरिकल्स पे, लेंस के न्यूमेरिकल्स पे। ओके, तो उसे ध्यान से देखिए, और अगर आपको वीडियो पसंद आया हो तो लाइक, शेयर एंड सब्सक्राइब करना ना भूलें। थैंक्स ऑल ऑफ यू, बाय देन।